Hi guys, welcome to Tech. Today we're gonna build a ultrasonic sensor which senses distance and prints on this LCD monitor. So first, let's connect the ultrasonic sensor and the LCD to the Arduino Uno. As you see, I've already set up the 5 volts and the ground from the motherboard to the Arduino, so it makes it easier to use just one 5-volt pin for two devices. So first let's connect the ultrasonic sensor. I've got some jumper wires over here. So there are four pins on an electronic sensor, on an ultrasonic sensor: the trig pin, the ground pin, the echo pin, and the VCC, also known as the 5 volts. So the VCC goes to the 5 volts as spoken before. Then the trig pin goes to any pin you like, but I'm going to put the trig pin in pin number 2 on the Arduino. Next, I'm gonna connect the echo pin to pin number 4 as well as this pin. It's your wish wherever you want to put it, but you need to configure it in the Arduino code. I'll put it in pin number 4, and at the last the ground, which goes in the ground pin. Okay. Just like this, we have connected the ultrasonic sensor correctly to the Arduino Uno. Now we put the ultrasonic sensor side and pick up the LCD. Now the LCD is very similar to the ultrasonic sensor. The pins are the same, but instead of the echo pin and the trig pin, the LCD has a SDA pin and a SCL pin. This LCD is a IC2 LCD, so it only has 4 pins to connect, unlike any other LCDs. So let's take a first jumper wire and connect the ground pin to the ground as usual. And the VCC to the 5 volts. The SDA to any pin you wish, but I'm going to put it in analog 4. It is recommended if you put the SDA pin and the SCL pin in the analog sector of the Arduino. The SCL goes in analog 5. Now if you connect the Arduino to your PC, you will see that the LCD will flash, and it's just gonna perform a task because it's already in the memory of the Arduino. The ultrasonic sensor won't give any light or signal that it is on, but if you have connected it properly, then yes, the ultrasonic sensor will work as normal as it does. So let's get on to the code now. So as you can see here, the code is simple. It's not that of a complicated code. So first, in these two lines, so let's start at the beginning, sorry. So in these 3 lines, we include the wire library and the liquid crystal I2C library if you have a I2C LCD. If you don't have a I2C LCD, just include the liquid crystal library. And then we make a variable for a LCD and we give the dimensions. These 2 pins are configure the trig pin and the echo pin for our ultrasonic sensor, and it's recommended if you give variables for the pins and stuff before the void setup, so we can change it easily instead of going to the setup and changing every pin and finding every pin and changing them. So this is the duration variable and the distance centimeter variable for the ultrasonic sensor to sense the distance of an object. In the void setup, we begin the LCD and give the LCD a backlight. This command just brightens the LCD, and the next two lines take the variables the echo pin and trig pin, and we just configure it over here. Trig pin is output and the echo pin is input. It's very important to remember the output and input of these two variables. Second, this is optional. As I have a YouTube channel, I've said this, but this is optional. At the beginning of the program, I've set my LCD cursor to row number 0 and column number 0, and we print welcome to, and then we set the cursor to the second row and the first column and print rate tech. This is optional. If you want to do something like ultrasonic sensor distance measurement, you can print it over here. And now we come to the void loop. First we call out this command, which is below over here. This is to start the ultrasonic sensor. We first write the trig pin as low, then the trig pin as high, and then again low. This variable gets the echo pin of the ultrasonic sensor and pulses it in. And this is a command which converts duration into distance centimeter. If you want to convert this into meter, you can check it on Google, but still I'll try my best to find it on Google, and maybe I'll put it in the link in the description. I'll put the link in the description. So we call out this function at the beginning of the while loop, and then we clear the LCD, as we don't want to print the distance centimeter on top of the previous text. We clear the LCD, set the cursor to 0 column and 0 row, and then we print the distance centimeter, and then on the same line we print the distance centimeter variable as it is mentioned over here. Next we make an if statement. This if statement says that if the distance centimeter is less than 6, then the LCD dot set cursor on row I messed this up. LCD dot set cursor, messed that up. So we've set the cursor. Oh my god, set cursor. It happens. So we set the cursor to row number first and print to close, and then we do the same with the to high print. We check if the distance centimeter is greater than 200. Then we do the same. We put the cursor at row number 1 and print to high. So this is it. The code is simple, not very complicated. Now if we connect this, first we'll verify if the code is correct. I would recommend you to verify after every program, so it just checks the code. If it is correct, then upload, so we'll be sure that there is no problem in the code. Okay, now it's done uploading. I'll show you the results. So after we upload the code to the Arduino, we see that the LCD starts printing out the distance and the ultrasonic sensor works. So now we pick up the ultrasonic sensor, and when we put the hand close to it, it prints the centimeter, and it also prints below the line too close or too high. Now if we put it over here, it senses 25 centimeter, and if we just take out the hand, it will sense objects which are 400 to 500 centimeter far from it. So thank you for watching. Please share, subscribe and like this video, and see you on the next video.